Good afternoon, guys. Just confirm you can hear me.
Yes, sir. Good afternoon, sir.
Good afternoon. Okay, yesterday in last class we have finished the vibration. I hope everything is clear in the vibration.
Yes, sir.
Okay, very good. You will be able to explain all
Yes,
axial
sir.
vibration, torsional vibration,
Personal vibration.
counterbalance weight, Bart speed range,
Yes, sir.
right? First order
Yes.
moment, second order moment, why they are in which direction they are acting, what is one node, what is first order,
First order,
if
second order.
one node in
Yes.
per cycle, that is known as first order. Okay,
Yes.
so today we are going to discuss something new. You must be aware of your boiler water test, right?
Yes,
But
sir.
on board what we are doing using our kit, surveyor are not interested in that, right? If you tell I'm checking this PL Canity and all those things, no surveyor recognize the test what we are doing on board the ship, right? Or they are accepting that answers.
Yes, sir. Very difficult day, sir.
They are not accepting all these answer because in their time they were doing something else. So we have to go,
Laboratory test.
we have to travel back and see how they were doing. Okay. I can see some new faces today, like Victor and Saitej. I hope I'm pronouncing your name correct, Saitej. You guys are there, Victor and Saitej.
Yes, sir. Victor, I am present, sir.
I think Victor, you attended few classes before, right?
No, sir. This is my first class, sir.
Ah,
Yesterday,
this is gonna be your first class. So you will be appearing from which MMD?
Chennai, sir.
Chennai. What about Saitej?
Sir, I'm giving from Bombay.
Mumbai. So for both of you, this is gonna be your first attempt, right?
Yes.
Okay, very good. So today we will be discussing about boiler water test or boiler water treatment. We will see first why we are doing it. Why we want to treat our water. We want to treat our water? Any idea?
Yes, sir. To increase the efficiency of boiler and reduce the corrosion and unnatural damage from water. Basically, sir, it will reduce the efficiency of boiler and reduce the failure of mechanical damage cause of corrosion. Hello, sir. Hello, sir.
Really sorry, guys. My internet got interrupted in between. Just give me a few minutes so that I can log in using my laptop also.
चलो ठीक
Okay, guys, we'll start now. Really sorry for the interruption. Who is the host now? Saitej, can you make me host? Do you know how to make host?
I'm doing it, sir.
Yeah, go in the participant. You will find my name.
I've done it.
Now Kumar is the host. Kumar,
Yes, sir.
Okay, I've made Kumar as a host. Okay.
make me host. The one mic is open. I am logged in using two ID. One is Tarun, other one is Zoom. So make host the Tarun. Just touch on the participants. Laptop. Kumar.
Yes, sir, I did, sir.
Okay. Thank you very much. So first thing what we were discussing. I hope you can see the slide. Oh my God, this
No, sir.
network is slow. They're talking about 5G and all, but you can't even connect your phone and laptop together. Guys, I hope you can see my screen now.
Yes, sir.
Yes, sir.
Okay. So what happens when scale is going to get deposit? Obviously, the heat transfer will be less, and the heat is going to transmit to that material, and then your material failure can be possible. So when we talk about hardness, there are mainly two type of hardness. One is temporary hardness, other one is permanent
Permanent.
hardness. So temporary hardness is because of the alkaline hardness. Because of the alkaline things, what
System, sir.
hardness we have is known as temporary hardness. And when it is because of the non-alkaline things, that hardness is known as permanent hardness. Okay. Okay, we will just go ahead and we will see more things. Temporary hardness, alkaline hardness is due to bicarbonate. It is because of the bicarbonate of calcium and magnesium, which are alkaline in nature. So it is because of the bicarbonate of calcium and magnesium, which are alkaline in nature. They are temporary because when heated, they rapidly break down to form the carbon dioxide. When you are going to heat them, they will form CO2 and the corresponding carbonate which deposit as a scale. And the remaining like calcium and magnesium, they are going to remain as a scale. Next one is permanent hardness. Permanent hardness is because of the non-alkaline hardness is due to the mainly of due to sulfate and chloride of the calcium. So because of the bicarbonate, you are having the permanent temporary hardness, and because of the sulfate and chloride of magnesium and calcium, what you are having is known as the permanent hardness. They are not they are permanent and they don't break down, but under certain condition deposit from the scale may vary hardness. So can you see in the temporary hardness what are the material which are making temporary hardness? Calcium bicarbonate, that is CaHOC, HCO3 Vol2, and Second one is magnesium bicarbonate, where when you look at the permanent hardness, it is because of the sulfate, calcium sulfate, magnesium chloride. Understood the difference between permanent hardness and the temporary hardness?
Yes, sir.
Okay. Sometimes they are asking these small questions. Okay, especially Pakrasi sir. Next is boiler corrosion. Boiler corrosion. Why corrosion is happening?
Hydrogen and oxygen, hydrogen ions.
Water
Water
contains hydrogen and as well as hydroxyl ion, that is H plus and OH both. The product of concentration of ion is always should be between 10 to 14. So this is the pH of the water we should keep at 25 degrees Celsius. So when your solution is having pH like 5, it is known as acid, 7 is neutral, and more than 5 is alkaline. With increase in temperature, increase in concentration of hydrogen ion. So when you increase anything's temperature, like water, so it will liberate hydrogen plus ion and hence increase the acidity. So you are increasing the plus ion, hence increase the acidity. Electrochemical corrosion, pH value is very important. pH value is very important in the electrochemical corrosion. Electrochemical corrosion means what? When two material are electrolytically kept in same container,
Yes,
one
in solution, sir.
in a solution, then atoms from one will transfer to the other, right? That is known as
Yes.
electrochemical corrosion.
Yeah,
So
more active metal sacrifice.
yes, pH means the pH is the measurement of number of active acid or base substance in a solution. pH is negative logarithm of hydrogen ion concentration. So how much is the negative value on the hydrogen ion? So same pH is very important factor for determining whether the water has a corrosive or scale forming tendency. Water with a low pH give rise to the corrosion. That is why we want to keep our water little bit alkaline. Basically, it tells us acidic or alkaline a particular solution. Its range is normally between 0 to 14. pH value indicate 7 indicate neutral, 7 to 14 is acidic, and below 7 is 7 to 14 is alkaline, and below 7 is acidic. Problem associated with the boiler water. So what are the problem? These are the three main problem which are associated with the boiler water. First one is corrosion, right? Second one is scaling. Third one is carryover. So first one is corrosion. Look at the diagram. This is the normal pipeline looks like. But when your pipeline is under corrosive attack, can you see the thickness of the pipeline is decreasing on one side? Can you see? They are decreasing. So
Yes.
general corrosion is known as general wastage in overall reduction of metal thickness. So here the overall metal thickness is getting reduced and is common in heating surfaces like boiler tube. So it is a general wastage which is occurring, and because of that metal surface is getting reduced, and it is common in the high temperature surfaces like our boiler tubes. Next one is pitting corrosion. Pitting corrosion means what? Can you see this small pit?
Erosion, sir. Material eroded from place.
So pitting corrosion forms irregular pit. They are forming irregular pit in the metal, as we are showing in the figure. Normally found in the boiler shell around the water level. So corrosion was where? On the tube, whereas pitting is on the shell, right?
Yes.
Normally found in the boiler shed around the water level, where your water level is just touching. Means what? Suppose this is your water level, so it will found in this area. Because what happen? You fill the boiler, right? You are filling up to air. Your pump stop or your three-way valve get operated. Then when level will be here, it is going to start again. So in this area, the water level is changing again, right?
Yes.
Okay. So that is the reason we found it in the around the water level area. Cause because of the inadequate oxygen scavenging. So if there will be inadequate oxygen scavenging means what?
Less
There
amount
are
of oxygen. Yes.
sorry, please go ahead.
Very minimum amount of oxygen. So we have need, sir, adequate amount of oxygen content also in water.
No,
If we remove all oxygen, then it will cause pitting.
no, we have to remove all the oxygen. Scavenging in mean what? You want to remove the oxygen. So if you are, how you are removing the oxygen?
By heating water and
By
adding
keeping your
hydrogen.
cascade tank temperature high,
Yes.
right? So if you are not maintaining your cascade temperature as per the recommended value, the oxygen scavenging will be inadequate.
Sir, one my question, sir.
So
If
how
sir,
pitting? Hmm.
sir, if my question, sir, if I remove sir total oxygen from water, sir, then what will happen, sir? We have need
Nothing will
some
happen.
amount of
No, we don't need oxygen. Why we need oxygen?
some survey. One type of survey asked from another one, sir. Minimum amount of oxygen must be in water.
But anyway, you cannot remove all.
Yes, sir. That's why asking, sir, how much quantity of oxygen what?
But there is no regulation on the quantity. We are just maintaining the temperature.
Okay.
So if you are not going to maintain the temperature, then this is going to happen because there will be a oxygen inside your boiler water. Okay. So now you see calcium is already there. So they will fall calcium hydroxide, right?
Yes.
Magnesium hydroxide if excess oxygen.
Yes.
So pitting, how pitting take place? This is the full reaction in step by step how it take place. It is a local chemical or mechanical damage, right? This is the
Mechanical damage.
local chemical mechanical damage to the protective oxide film. So on the pipes, on the shell, we have the protective oxide film. It is going to damage that oxide film. Poor coating of oxide. Suppose when you are doing the coating only, the coating was not proper, then also pitting can be initiated, and presence of non-uniformities in the metal. These are the condition when your pitting will take place. Local cell that lead to the initiation of a pit can be caused by abnormal anodic site surrounded by the normal surface such as which act as a cathode. So we already discussed electrolytic reaction, right? So
Yes.
where the surfaces will be abnormal, that site will become anodic, and normal site will become cathodic, and then from the anode metal will come out and go towards the cathode, right? So you will be having a pit kind of formation here that is known as pitting corrosion.
Electrochemical. Yes. Electrochemical.
Next one is stress corrosion. Stress corrosion, why it's caused by the combination of heavy stress and the corrosive corrosion. So combination of heavy stress, obviously our boiler is under heavy stress. If you are on a bulk carrier or container, you might be only having 7 bar, but on tanker we are going up to the 16 bar, right?
Yes.
So this is the problem, and it stress corrosion occurs because of the two combined thing. One is heavy stress is there, and other one is corrosive corrosion. Corrosive corrosion is which one? This corrosion, right?
Yes.
Normal corrosion, that is the general wastage of our material. Stages of stress corrosion. Corrosion is initiated by the breakdown of the surface film. Same here, breakdown of the protective oxide film, right? So first it will get initiated when your oxide film is damaged. Like here, the film was breakdown. Can you see X everywhere? But here X is gone, means here the protective film is breakdown. Then the corrosion uh, pit will form. So then what will happen? First pit will form, right? Yes or no?
Yes, sir. Will form.
Then formation of the pit. This is making the pit. formation of the pit, and this will become site for the stress corrosion. Now, in this pit, stress corrosion will occur. This is the preparation for the stress corrosion. Now, finally, stress corrosion will take place. This is normally found around the auguring. What is auguring?
If sir combustion attached with the boiler cell, sir, there have sir auguring. Combustion furnace, sir.
If you are following question, surveyor is asking what is auguring, right?
Basically, sir, it attached sir furnace to boiler cell,
Yeah,
sir.
okay, you are correct. But we will see in deep when we will doing the boiler. Okay, just for the time being, remember the area. So where your corrosion was occurring?
Auguring area.
Where your corrosion was occurring, not stress corrosion, general corrosion.
Corrosion.
On
General
the tube,
corrosion, sir, water tube, sir,
on
and
the tube,
water cell,
where pit corrosion was taking place?
water tube, water cell, sir.
On the shell, on
Yes,
the where your water level is changing, and
yes.
your
Tube
this kind of corrosion is taking place on the auguring. Okay,
furnace.
when undue stress is kept up by the poor steam raising procedure. So when you are having poor steam raising procedure means what? Suppose your boiler was cooled down and you directly increase the pressure to 7 bar, then there will be heavy stress, right? If you are increasing slowly, obviously your material will be getting condition, right? Okay. Then after formation of the pit, stress corrosion will take place and it will crack the material. And finally, your material is going to get the fail. This is the process by which stress corrosion take place. Next is fatigue corrosion. What does fatigue corrosion means?
Fatigue corrosion means sir, where fatigue occurs between sir two surfaces due to cyclic loading on changing pressure continuous.
So it is the combination of corrosive action. First we need corrosion and cyclic stress, right? Fatigue is only cyclic stress, right?
Yes,
So combine is fatigue is cyclic stress, corrosion is corrosion. So it's combination of corrosive action and the cyclic stress result in the series of fine crack in the metal that is known as fatigue corrosion. I think you must have seen this question, caustic corrosion,
favorite question sir, MMD sir.
right? So what is caustic corrosion?
Caustic corrosion sir, it means sir where sir alkalinity level increases sir.
Okay, we'll just see. So in high pressure boiler, so it occur in the high pressure boiler, usually indicate by gauging the tube. So when you are going to measure the thickness of the tube, you will going to get to know whether there is caustic corrosion or not, caused by the excess sodium hydroxide. So if excess sodium hydroxide is present in the water, then caustic corrosion will take place. In this corrosion, the protective magnesium oxide iron film, that is Fe3O4, magnesium is, by mistake I've written magnetic, magnesium oxide iron film,
Magnesium
F,
sir. Yes, magnesium
Fe3O4
peroxide. Yes,
get damaged and base
yes,
metal become exposed. So first your film is going to get damaged and then finally your base metal is going to get exposed. Same here it happened. First this film got damaged, right? Then our base metal got exposed, then pitting take place, then stress corrosion take place, right?
yes.
Similar. Base metal is attacked by the high concentration of sodium hydroxide. So your base metal is getting attacked by the high concentration of sodium hydroxide, then this type of corrosion take place. If the concentrated layer of boiler water is alkaline, so if your boiler water is alkaline, the metal pick up progress as expressed in the following formula. So iron is there in the tube, right?
Yes.
This is sodium hydroxide. What it will form? It will form Na2 FeO2 plus 2H. Now this FeO2 Na2 FeO2 is going to react with your water. It will again form
Sodium
6NaOH,
hydroxide.
and this is corrosion, right? Fe3O4. This is the
Fe2
corrosion.
iron. Yes, sir. Sodium hydroxide plus iron oxide.
Yes. So this Fe3O4 is corrosion, right?
Yes, sir. Sodium hydroxide, sir. Corrosive.
Iron, this thing, what we call it,
I-
iron
Iron oxide.
oxide.
Yes, iron oxide.
So this is how there was a iron and it converted into iron oxide. So this is the combined reaction. This is 3Na Fe2, right? Now this is 3H2O, half O2. When they are going to react, it will form 6NaOH plus
Fe3O4.
Fa3O4. That is the corrosion. So if there is dissolved oxygen in the boiler water at this point, further reaction will take place. So now if there will be dissolved oxygen, further reaction take place. That is Na3PO4 plus 2 molecule of water, 0.2 molecule of water. It is going to make precipitation. Na2.8, 0.2 PO4 and sodium hydroxide, that is caustic soda, right?
Yes, sir.
And
Sodium
the
hydroxide.
and this had taken place because of this corrosion have taken place because of the caustic
Caustic.
soda. That is why it is known as caustic corrosion.
Excess chemical involved.
Excess alkalinity of your boiler water,
Boiler
not
water.
chemical. Okay. So the phenomena of caustic embrittlement. This sometimes they are asking like this only, embrittlement, caustic embrittlement, or
Yes, sir.
intercrystalline fracture is believed to caused by the high concentration of caustic
Caustic
soda,
soda.
that is sodium hydroxide, which dissolve the iron in the boiler component and make the material under
Under.
stress. The stress corrosion crack will follow the grain. Now what will happen? It make the material under stress. Now stress corrosion will take place. Stress corrosion crack follow the grain or crystal boundary of the material, and failure of the affected part could result in the high level of, if you are maintaining high level of caustic are maintained. This sodium hydroxide attack the surrounding water. Now your sodium hydroxide is attacking the surrounding water and then dissolve the iron of the boiler as a sodium ferrate. The concentration of the sodium hydroxide required for embitterment to occur vary with the operating condition of boiler. Normally, such concentration would not be found in the boiler, but any slight leakage would cause the high concentration required. So if there is any leakage anywhere in the boiler, like your gauge glass, this is the some joint, some manhole is leaking, then in all this area they are going to make this corrosion. Sodium hydroxide depress the solubility of sodium sulfate. So your sodium hydroxide don't let the sodium sulfate to dissolve. However, sodium sulfate can made be precipitated, but your sodium sulfate can be changed into the solids. It can change into the solid and provide protection against the caustic embrittlement. But this is your, so if you are having sodium sulfate, it can protect give you it can give you protection against the caustic embrittlement.
Embitterment. What
So
we what chemical, sir? Sodium.
sodium sulfate,
Sodium sulfate. Sodium sulfide. Yes, sodium sulfate. Both are same, sir.
yeah, same only.
Okay, okay. And sodium nitrate we also use.
Yes, everything will come slowly. A ratio of sodium sulfate to the caustic soda for a given pressure will provide a safeguard for the boiler part. It is recommended ratio of the sodium sulfate to the caustic soda should not be fall below 2.5 times. So your sodium sulfate should be always more than 2.5 times of your caustic soda. Then it is going to give protection to your materials. Other substances that have been used as inhibitors against the caustic embrittlement are cubraco, tannin, or sodium nitrate.
Sodium
So
nitrate.
if surveyor is asking you what is this
Chemical.
caustic corrosion, so it happens because of the high concentration of the sodium hydroxide, and then try to explain that sodium hydroxide reacts with the water, reacts with the iron and make the iron
Sodium, iron
oxide.
oxide and sodium. Yes.
So if we want to control this, then we should be having enough amount of sodium sulfide or sodium nitrate, or this is one more chemical,
Sodium
cubracotenin, so that we can use them as a
heptatotenin.
inhibitor for the caustic embrittlement. Understood?
Yes, sir. Two chemicals are enough, sir. One chemical we cannot remember.
Yeah, but obviously, if you can tell two also, that will be sufficient.
Yes. Sodium nitrate and sodium sulfate.
So the next one is
Factor which affect
factor
corrosion.
which affect the corrosion. So what are the factor which affect the corrosion? Metal oxide are soluble as pH decreases, right? It's
Yes.
because your solution is getting acidic, and corrosion will also increase. Dissolved solid chloride and sulfate can penetrate passive metal oxide film, which protect the base metal from the corrosion. So if you have a dissolved chloride sulfate, then they can go into the grain structure and damage the metal. If you have the dissolved gases like carbon dioxide, H2S, they reduce the pH.
Yes,
They
sir.
reduce
Carbon
pH
dioxide.
and promote the acid attack.
Yes.
Oxygen promote the pitting
Mm.
corrosion. Right? We already studied this.
Oxygen
Next
promote the
is,
pitting corrosion. Yes.
yes. Next is if you have the suspended solid, mud, sand, clay, etc., settle to form deposit, promoting different corrosion cells. So we are talking about here what? Electrochemical corrosion, right?
Yes.
And these all react as a, they are form oxides and make one metal differ from the other, although they are the same metal. Next one is microorganism, promote different corrosion cells. So microorganism are and copper ion plate out on the steel surface and promote pitting corrosion. Copper also promote the pitting corrosion. So these are the factors which affect the corrosion. If surveyor is asking you what are the factor affects corrosion, you can tell all these factors. Next is scaling. So what is scaling?
Scaling means if due to excessive heating in boilers, so scale formation will there.
Because we have the some material like calcium chloride, calcium sulfate, magnesium chloride, right? All these are temporary and permanent, having the temporary and permanent hardness, right? Sulfate, their sulfate also. So what happened? Hardness in the boiler water will inevitably lead to the formation of scale. If there you are having either temporary hardness or permanent hardness, both are leading to scale. And rate of formation will depend on the composition and quantity of hardness, on the temperature condition in the boiler and the circulation in the water. So what is the temperature? How much water is getting circulating? All these depend on all these factors. Your scaling depends. Increased surface heating effect means increased production of steam bubble. If your surface heating is more, you are producing the more steam bubble, which again will make the boiler water pass the spot on the heating surface wherein the steam producing bubble are formed, and this spot will thus be also be passed by the hardness producing and corroding salt in the boiler water. Most of the common hardness salt are soluble of increasing temperature. This explains the largest amount of the encrustation will always be found where the temperature of the heating surface is highest. Scale form just at this point means that the critical temperature of the boiler material will be reached quickly and damage to the boiler tubes or boiler shell will be inevitable. So now you see this is the water side, this is the fire side. Your boiler is clean. So can you see small deposits here? Can you see small deposit here? Can you see one extra line in this one when you're comparing both the figure?
Yes, sir. Yes, sir.
So these are the scale, and when scale forms, can you see temperature is reducing different in the different graph? We are following some different graph only. So the scale caused the fuel consumption to increase by 18%. So when there will be scale, your fuel consumption will increase by 18%. Stress will arise in the steel as a result of the insulating effect because your scale give the insulating effect. So guys, tomorrow we will see what is carryover. Okay, after carryover, we will see the cause of the carryover, what is priming, what is forming, and your boiler water summary, what all things you have to maintain. Then we will start with the boiler water treatment. Right now we are studying why we need to treat our water, right? Then we will start the boiler water treatment. We will do the following test: alkalinity, phosphate reserve, dissolved oxygen reserve, feed water hardness, dissolved solid, hydrogen. We are going to study about all these tests. Then boiler blowdown, boiler water test, like your alkalinity test, total alkalinity, and these are the favorite question of the Pakrasis sir, right? He say sometimes he say your P alkalinity is equal to T alkalinity. What does it mean, right? He's asking all these questions. Have you seen these questions? Okay. But if you are going to see the question of the Pakrasi sir, this particular slide is favorite of the Pakrasi sir. So tomorrow we are going to see his question also. What will happen when P alkalinity is 0? He asked that why P alkalinity should be equal to half of T alkalinity. He is asking all those things. Then we are going to study all these. Caustic alkalinity, we are going to study the test. Chloride test, sulfide test, phosphate test. We are going to study all this tomorrow. And obviously, what test we are doing right now, we are not doing as per these name, right? Are we doing as per this name?
No, sir, no.
So that is the reason what we tell them, they don't understand and they can't correlate what we are saying. So tomorrow we are going to see how they were doing the test, boiler water test when they were on board. Okay. Tomorrow we are going to see that. And that's all for today. Today link was late. I don't know why. So if you are like our class is at 1300, if you are not getting link by 1300, just you can put the message in the groups. Okay. So that they know they have to put the link.
Okay, sir.
Okay, guys. I hope lecture is useful. You are learning something different what you have learned earlier in the boiler water.
Yes.
Yes.
Okay, guys. Thanks for your time. See you tomorrow.
Thank you, sir.